As with other types of functions we've studied, there are times where we essentially need to work backwards. We need to undo them. So in the case of trigonometric functions, for sine or cosine or tangent, we generally know what the angle is. So say sine of 30 degrees, cosine of 45 degrees, tangent of 225 degrees. And so we want the input is the angle, and the output is the ratio of sides of a triangle. So we can use the unit circle. We've done this work. Well, there are times where we know what the ratio is, and we want to work backwards and figure out what the angle is. So that means we're looking for the inverse of one of these functions, sine or cosine or tangent. The problem is, if we look at the graphs of sine and cosine and tangent, they all fail the horizontal line test, which is our test that we used previously to determine if a function has an inverse or not. So for example, if we think back to a graph of something like this, a cubic function of some sort, that was an invertible function. It had an inverse over its entire set of values. On the other hand, if we had a parabola, we knew that that was not invertible because it failed the horizontal line test, which meant the inverse, when we flip-flopped the x and y's, was not going to be an inverse. And so what we did in that circumstance is we restricted our domain. We said, all right, we'll cheat and we'll just basically wipe out half of the graph and say that we're only going to consider the inverse for values where x of the original function is greater than or equal to 0. And so that's what we do with these inverse trigonometric functions. In order for us to get only one output, one angle for every input, for every ratio, we have to restrict ourselves to just a small portion of the original sine or cosine or tangent curve. And so the part of those curves that we use to determine what is the one answer that we're going to accept for the inverse of one of these functions is called the principal branch. And so for each of these curves, we have one part of the curve that passes the horizontal line test if we just slice out that one piece that serves as our principal branch, and therefore we'll only look for angles that are associated with that part of the original curve. So for example here for the sine curve, so we can see quite clearly it fails a horizontal line test, just the x-axis alone crosses through it many times. But if we just take that portion that's there in bold, the part that's between negative pi over 2 and pi over 2, then it will be invertible. So that means when we want to find the inverse sine of some ratio, our answer will only be an angle that's between negative pi over 2 and positive pi over 2, between negative 90 degrees and 90 degrees. But we can't use that same range of values for the outputs of the inverse cosine function, because if we look at the cosine graph, if we were to use the same negative pi over 2 to pi over 2 section of the graph, that would fail the horizontal line test. We need to make sure that we excise a part of the graph that passes the horizontal line test. And so the way we do that is by changing the set of values for which we'll accept answers for inverse cosine. And so for inverse cosine, the range of values that we're going to accept are from 0 to pi. Now, in both these cases, the domain is negative 1 to 1 because the smallest sine ratio you can have is negative 1. If we think of our unit circle, that happens at the bottom of the unit circle at negative pi over 2 at 3 pi over 2. And then likewise, the largest y value that we can get for sine is 1. For x, again, negative 1 on the left at pi, positive 1 on the right at 0. And so that's our domain for both of those functions. But our ranges are different because one is tracking with the y coordinate on the unit circle, whereas the other is tracking with the x coordinate. And so that's why we have these two different ranges. And we can see that from the graphs of these functions. So we have these two principal branches that are selected such that they'll pass the horizontal line test. Tangent, we can see also fails that horizontal line test. So we again are going to only use one part of the tangent function to serve as our principal branch. And so that is going to be this one right here. It's not highlighted for us in the diagram, so I've done it for us here. And so that also is from negative pi over 2 to pi over 2. Now, one subtle thing that I'll point out in the difference between sine and tangent, you'll notice that there's no equal to in the range for tangent like there is for sine. And the reason is tangent, as we hopefully remember, is undefined at the over 2's, at pi over 2, at 3 pi over 2, at negative pi over 2. And so therefore there's no ratio that we could plug in to the inverse tangent in order for us to get pi over 2 as an output, as an answer. So let's see what this looks like in practice. Now, one thing that may be handy for you is to have a unit circle in front of you so that you can refer to that, because in each of these cases what we have here is a ratio that's being given to us. That's the input into these inverse functions. And so the output is going to be an angle. But again, it has to be an angle that is consistent with the ranges that are outlined just up above on your paper or on the previous slide. So when we say what's the inverse sine of root 2 over 2, there are an infinite number of angles that have a y coordinate of root 2 over 2. In fact, on the unit circle there are two of them. It happens at pi over 4 and it happens at 3 pi over 4. Both of those have a y coordinate of root 2 over 2. But the only answer that we accept for inverse sine of root 2 over 2 is pi over 4, because that's the angle that is in that range, that is along that principal branch from negative pi over 2 to positive pi over 2. Take the next example, inverse sine of negative root 3 over 2. So when is the y coordinate negative root 3 over 2? Well, again, there's two angles on the unit circle alone. If you consider all the angles that are coterminal with those, there are an infinite number of angles that have that sine ratio, that have that y coordinate. But the only acceptable answer is actually not even one of the angles that's on our unit circle that's labeled that way, because it's got to be between negative pi over 2 and positive pi over 2. So the angle at 5 pi over 3 is coterminal with the answer that we want, which is negative pi over 3. That's the angle that is between negative pi over 2 and positive pi over 2 that falls on that principal branch highlighted on the previous slide, that has a sine ratio that has a y coordinate of negative root 3 over 2. And then for the last one in this row, inverse sine of negative 1. So we know from our unit circle that's the bottom of the unit circle, but I cannot put 3 pi over 2 as my answer, even though that's the location on my unit circle where that happens. I need to make sure that the angle that I give is between negative pi over 2 and positive pi over 2. And so negative pi over 2 is the angle that is coterminal with 3 pi over 2. So that is the answer. And if you were to push buttons on your calculator in all these cases, do the inverse sine. So on your scientific calculator, or on the Inspires, or on the TI-83s, you can access these inverse sine, inverse cosine, inverse tangent. We've used them to find the measure of an angle, like on the angle of elevation, angle of depression questions from our quiz. And so if you push buttons there, it only gives you one answer, and that answer will be within the negative 90 to positive 90 range if you're in degrees, or in the negative pi over 2 to positive pi over 2 range if you're in radians. For cosine, so the next row of problems, remember cosine is now from 0 to pi. So if we think of our unit circle, it's the top half of the unit circle rather than it being the right-hand half, because by going from 0 to pi, from 0 to 180, we're making sure that we capture all of the possible x values, all of the possible cosine values. So when it says inverse cosine of 1, I look on the unit circle to see where is the cosine ratio, where is the x coordinate 1, and so that happens at 0. I'm not going to put 2 pi as an answer because, again, that does not fall within the range listed above of 0 to pi. Inverse cosine of negative 1/2. So now I'm looking on my unit circle to see where is the x coordinate negative 1/2. There's multiple angles. There's there's 2 pi over 3, and there's 4 pi over 3. But 4 pi over 3 doesn't fall within the accepted range, so the only answer I'm going to take is 2 pi over 3. And then finally, inverse cosine of negative 1. So I look to see where the x-coordinate is negative 1. That happens at pi, and so that's my answer. It's acceptable within the range of 0 to pi. Tangent is the trickiest of the bunch because now we're not looking for just a individual x-coordinate or an individual y-coordinate like we are with cosine or with sine, but now we're looking for that ratio. Now the easiest ones are the ones and negative ones. So when we're trying to find what is the inverse tangent of 1, that means that the x-coordinate and the y-coordinate must be the same because tangent is y over x. And so that happens in two locations. It happens at pi over 4 in the first quadrant, and it happens at 5 pi over 4 in the third quadrant, where tangent is also positive. But because of the restriction for the range for inverse tangent being between negative pi over 2 and positive pi over 2, the only answer that we'll accept is pi over 4. Root 3 over 3 is a tangent ratio. What angle has that? Well, multiple angles again, but the only angle that we're going to accept is going to be one that's in the first quadrant because that's between negative pi over 2 and positive pi over 2, or we're going to get positive tangent ratios. And in that case, because root 3 over 3 is less than 1, that's implying that the y-coordinate is smaller than the x-coordinate, so that's happening at 30 degrees at pi over 6 in radians. And then lastly, inverse tangent of negative root 3. So now I need to have a negative tangent ratio. Well, that happens in the second and fourth quadrants. So since we're between negative pi over 2 and positive pi over 2, that means we must be down here in this fourth quadrant. But we're not going to describe it as a fourth quadrant angle. We're going to describe it as a negative angle rotating from the positive x-axis. And so this time with a tangent ratio of negative root 3, that means the y-coordinate is bigger than the x-coordinate, and so therefore we must be at negative pi over 3. It would be 5 pi over 3 on our unit circle, but because our answer has to be reported as being between negative pi over 2 and positive pi over 2, we're going to give it that negative pi over 3 value. That's the only answer that's acceptable in this case.